All right, welcome to the video review on quadrilaterals. Okay, so remember, a quadrilateral is a four-sided polygon, and so there are four particular quadrilaterals that we discussed this year, and so that's a parallelogram, a rectangle, rhombus, and a square. So remember the parallelogram, they have opposite sides that are congruent, opposite angles that are congruent. Their diagonals bisect each other, although they don't have to be congruent. And their same side interior or their consecutive interior angles equal 180. Okay? The properties of a rectangle has everything that the parallelogram has, and also all the interior angles are equal to 90 degrees, and the diagonals are congruent. So not only do the diagonals bisect each other, they're also congruent. Properties of a rhombus. A rhombus has everything that a parallelogram has. It has the diagonals are perpendicular and the diagonals bisect each other. Okay? In a rhombus, the diagonals do not have to be congruent, but they do have to bisect each other. They bisect each angle that they come in contact with, and the diagonals are perpendicular. In the properties of a square. A square is like the baby of the quadrilateral family. It has all the properties of everything else. So it has all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. So it is very important that you really understand all the properties and know what properties are associated with each shape. Okay? I'm going to go through the 6 example problems with you. Okay? So the first one, it says the design for a quilt piece is made up of 6 congruent parallelograms. So what is the measure of angle 1? So this is almost like a tessellation. And anytime you go around a central point like this, all of these angles have to add up to 360. Okay? And so if all of these are congruent, meaning they're all the same, each of these angles here is going to be the same. So we're just going to do 360 divided by, there's 6 of them. And so each one of those angles is 60 degrees, right? So that's 60 degrees and that's 60 degrees, right? And so now if this is a parallelogram, the 60-degree angle and the angle 1 are consecutive angles. And if you read up in your notes, consecutive or same side interior angles equal 180 degrees. So whatever angle 1 is, plus that 60-degree angle has to equal 180. So that means angle 1 is equal to 120 degrees. Okay? Let's look at example 2. If ABCD is a parallelogram, what are the coordinates of B? So remember, in a parallelogram, you have opposite sides that are congruent. So if side DC, I can tell because they're all on the same, they have the same y coordinate, so only their x coordinates change, and their x coordinates change by 5, right? So that means their distance between them is 5. So that means the distance on AB also has to be 5, the horizontal distance. And so the horizontal is done by the x value. So if A had a x value of 2, we add 5 to that, which will be 7. And then it has the same y value as A, so 3. So it'd be the order pair 7, 3, and that's D. All right, example 3. You want to know which of the following pieces of information would suffice to prove that this is a rectangle. So let's just look at each one. If we have that AC is equal to BD, so if I just mark that, AC, that is equal to BD, okay? And then we know from our properties above that diagonals of a rectangle are congruent. So that's telling me that the diagonals are congruent, so that one works. A works, okay? So I'm just going to erase that. When we go through B, B says that AB is equal to AD. So AB is equal to AD. Well, that doesn't really help prove to us that that's a rectangle, because that's not telling me opposite sides, opposite angles, any of that. So that one doesn't help us. So we can cross through B. Okay? C tells me that angle B is equal to angle D. So angle B is equal to angle D, which in a um, rectangle would be true because all the angles are 90, but they didn't say that's 90. So they could be anything. So that's just telling me that opposite angles are congruent, and that's any parallelogram, not necessarily a rectangle. So that doesn't tell us that it's a rectangle. And then in D, it says A and D are supplementary. So A and D are supplementary, which is true in any parallelogram because these would be the consecutive interior angles, or they would be same side interior, which they should add up to 180. Okay. Now, yes, in a rectangle, they both are 90, but that doesn't tell me that they're 90 degrees. All right. So the correct answer here would be A. All right, and question 4, it says in parallelogram ABCD, what is the measure of angle BDC? So remember, when we do our 3-letter angles, BDC, we're talking about this angle right here, okay? And so if this is a parallelogram, all right, so if I know that this middle angle here is 70, also know this is 70, I know this angle is 110, and this angle is also 110. Now, because this makes up a triangle, the 35, 70, and then this is the third angle that we can figure out is 75. And then we have another triangle up here, so we got a 110, a 25, which will make this 45. So this whole angle together is 120, okay? Now, that whole angle there and this whole angle there are consecutive interior angles, so they have to add up to 180. So if this angle A up top is already 120, then that means angle D altogether has to be 60. But if I know that piece of it is 35, then I'm going to do 60 minus 35, which is 25. So that makes this angle here 25 degrees. Okay. All right, next one. Which of the following quadrilaterals could have diagonals that are congruent but do not bisect each other? Okay. Well, if it's a parallelogram, all parallelograms have diagonals that bisect each other. So if these are a parallelogram, which a rhombus is a parallelogram, a rectangle is a parallelogram, and of course a parallelogram is a parallelogram, all three of those, A, B, and C, have diagonals that bisect each other by definition of a parallelogram. And so D is the only thing that's not a parallelogram, and they can have diagonals that are congruent, but they won't bisect each other. And number 6 says 3 vertices of a square have coordinates 5, 1, 2, -2, and 1, -1, 1. What are the coordinates of the fourth vertex? So I would plot those 4 points. And so when I plotted these 3 points and I'm trying to find the fourth one, well, I can see if it's a square, the diagonals have to be congruent. All the sides have to be congruent. And so if I go from this point here to this point here, they're on a straight line and they're 6 units across. So if that's a diagonal, then I'm going to go 6 units up from this one. And I end up being at the ordered pair 2. So 1, 2, 3, 4, 5, 6. And I'm at the point 2, 4. And then that makes the square. Okay? And you'll be able to check this. This side along with this side should have the same slope, okay, because they're parallel. And then this side along with this side, because they make 90-degree angles, are perpendicular, so you'd be able to check that slope. And then you can check the distance on all 4 sides to make sure that they're equal. Okay? And that's it.